Hello! Okay, so the purpose of this video is to show you how to solve radical equations. Okay, first what I'm going to do is I'm just going to show you this right here. This is actually from your textbook for those that got a textbook that attended physically. If you're wondering, this is section 11 3, page 558. But if you do not have a textbook, what I did was I just copied this excerpt from the textbook anyway. Okay, but to solve a square root equation, so in other words, this is a radical equation, or equivalently, something involving the power of 1/2, you can square both sides of the equation and solve the resulting equation. So squaring both sides may introduce an apparent solution that is not an actual solution. So that is called an extraneous solution or an extra solution. Kind of like what we did with rational equations, sometimes we had extra solutions as well. So for example, let's say we want to manipulate x equals 2 here. If we square both sides, we get x squared equals 2 squared, and 2 squared is 4. Then if we take the square root of both sides, remember the square root of 4 could be negative 2 or positive 2. But this is this idea of an extraneous or an extra solution. So what we started off with was x equals 2. But we know that x can't be negative 2 because negative 2 is not the same thing as 2 if we plug this back in. So that would, in that case, that would be our extra solution, and x equals 2 would be the only valid solution. Okay, so to start off, let's start simple. Okay? Let's start off with an example. Okay, so let's say for the first example, we have something like this. So we want to solve for x. Okay, so let's say we take the square root of x minus 9 equals 5. Okay, so what we want to do, what we want to do first is, as you can see, this radical is already isolated, and you'll see in the other examples that I'll show you, the radical won't be isolated. But since this is already isolated, what we can do is we can get rid of that square root somehow. So the inverse operation of taking a square root would be to square both sides. And that's what the description said earlier that I showed you. Okay, so what we have is the square root cancel with the square, and we're left with x minus 9 equals, so 5 squared, 5 times 5 is going to be 25. Okay, next what I see is we can solve for x. So we can add 9 to both sides, and then we get x equals 34. Okay, now, like I mentioned earlier, when you square both sides, you want to also check your work just to make sure that it works. So let's go ahead and plug this 34 back into what we have. So we're going to check. So we have the square root of x minus 9 equals 5. That's what we started off with. So we're going to take this 34 here, and we're going to plug it back in here. So by doing so, we get square root of 34 minus 9 equals 5. And then 34 minus 9 is the square root of 25. And the square root of 25, if we just take the positive solution to that, it's going to be 5. So 5 equals 5, and that just indicates that x equals 34. That would be our only solution in this case. So this is good. X equals 34. Okay? Right? So what that means is for this particular example, there actually weren't any extra solutions. Let's try to look at an example where we might actually have an extra solution. Okay? All right. Okay, so let's try to look at a new example. Okay, since I have 2 plus the square root of x plus 10 equals x. Okay, so first what we want to do, so if you look at the first example that we did, the radical here was already isolated. So since it was already isolated, we could just manipulate it right off the bat. But in this case here, we need to get this by itself, whether it's on the left-hand side or the right-hand side. So first what I see is we need to go ahead and take this number here. So we can subtract 2, and when that way we can isolate the radical. So this cancels, and we get square root of x plus 10 equals, now careful with this, I see here that some of you might try to combine like terms. These are not like terms. This is just x minus 2. Okay. Next, what I see is we want to get rid of this square root somehow. So recall what I said earlier. The inverse operation of a square root would be to square both sides. Okay, so let's go ahead and square both sides. So square root cancel with the square. And this part is where it gets a little bit interesting. So if we have x minus 2 squared, so I can see already that some of you already might make a mistake here and try to distribute that square. So recall that this is x minus 2 times x minus 2. Okay, I've seen this mistake come up a lot last year. So I'm hoping that I can address this to you guys now. Okay, so what we want to do with this is, now that we've written it like this, we can try FOIL or we can do box. Okay, so let's go ahead and let's say we do box. Okay, so what we have is we have x minus 2 and x minus 2. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is going to be positive 4. Now if we combine like terms, so this one and this one, we get x squared minus, so 4x, because negative 2x minus 2x can be negative 4x, and plus 4. So that is what comes here. So we have x plus 10 equals, and then we have x squared minus 4x plus 4. Okay, next what I see is we want to try to get all the terms on one side. So we can do something like this. We can subtract x, and then we can subtract 10. So subtract x, and then subtract 10. So we have 0 equals, so we have x squared minus 5x minus 6. Okay, so when we get to this step here, this should look familiar. So if you guys want to factor it, you can factor it, right? Or you could use quadratic formula. If you use quadratic formula, A is 1, B is negative 5, C is negative 6. But if you don't trust your factoring skills, go ahead and use quadratic formula. But if you guys remember how to factor, and if you try to find two numbers that multiply negative 6, add to negative 5, well, I believe negative 6 and positive 1 should work. Okay. Now, what we want to do is, if we go ahead and factor it this way, like actually if you use X method or whatnot, then what you want to do next is you want to go ahead and set each of these factors equal to 0. Now, so you do x minus 6 equals 0 and x plus 1 equals 0. I'm amazed. Some of you still can't do this. But it's okay. I guess part of the learning process, right? And we can subtract 1, and x equals negative 1. Yep. And then what we want to do here is we want to check to see if our solutions are valid. Okay, so let's go ahead and check. Let's try to check the first one, x equals 6. Okay, so if we try x equals 6 and plug that in, 2 plus the square root of 6 plus 10 equals 6. 2 plus square root of, well, 6 plus 10 is 16. And then we have 2 plus 4 equals 6. That looks like this solution is valid. This one is good. Let's say we try the other one, x equals negative 1. So if we try this one, 2 plus square root of negative 1 plus 10 equals negative 1. 2 plus the square root of 9 equals negative 1. We get 2 plus 3 equals negative 1. But what we get here is 5 is not equal to negative 1. So that means this one is not valid. So this we'd have to omit. And this would be the only solution. X equals 6 will be the only valid solution. Okay? So that is how this problem works. Okay? I'm going to show you another example. Right? Alright, so here's another example. Okay, so let's say I have the square root of x plus 3 equals x plus 1. So, like we have here, the radical is already isolated. So guess what we can do right off the bat? We could square both sides. Remember, the inverse operation of a square root will be taking a square. So what's going to happen in this case is square root cancel with the square. Get x plus 3 equals, And then x plus 1 squared is x plus 1 times x plus 1. Now let's say instead of box, we use FOIL, right? If you use FOIL instead and did this, so you do first, and then you do outer, inner, and then last. So we have x plus 3 equals x squared plus 2x plus 1 when we combine like terms here. Okay, next what I see is we want to get all the terms on one side. So we can subtract x and subtract 3. So subtract x and subtract 3. We get 0 equals x squared plus x and then minus 2. Okay, now what we want to do is we want to factor this, right? So if you guys remember how to factor, right? So we know x and an x here because x times x is x squared. We need to find two numbers that multiply -2 and add to 1 this time. So if we do that correctly, it should be +2 and -1. If you don't believe me, do the x thing and you can still get it that way. Okay, now what you want to do is you want to solve for x. So we have x plus 2 equals 0 and we have x minus 1 equals 0. So subtract 2 both sides, we get x equals -2. We can add 1 to both sides and we get x equals 1. Okay, so these right here are two possible solutions. But we also need to go ahead and check to see if there are any invalid ones. And sometimes that's the case when we go ahead and take the square of both sides. So let's try that. So let's say we try x equals -2. If we try that here, and we do that, so we're going to get -2 plus 3 equals -2 plus 1. So this means we're going to get the square root of 1 equals -1. So 1 equals -1, that's not true. So what this means is this one is not going to be valid, so this is not going to work. So now we got to check the other one. Let's check x equals 1. So if we plug this back into here, we get 1 plus 3 equals 1 plus 1. Square root of 4 equals 2. And 2 equals 2. That works. So what we have in this case is this is a valid solution. So this is gone. So only x equals 1 will work. That's the only valid solution. Right? Okay, so let's try another problem. All right, so let's look at what we have here. So we have -3 plus the square root of 15x plus 10 equals 7. Okay, so first what I see is we want to isolate this radical somehow, right? So in order to isolate that radical, what I see is we can go ahead and try to get everything on one side. So we can add 3, and look at this. These look like terms. So we get the square root of 15x plus 10 equals, and then we get 7 plus 3 is 10. All right, so we have a radical here. So since we have a radical, what we can do next is we can square both sides. Okay, so let's go ahead and do that. So the square root cancels out with the square. We're left with 15x plus 10 equals 10 squared is going to be 100, right? 10 times 10 is going to be 100. And then what we can do is we can solve for x. So subtract 10. So we get 15x equals 90. And then we solve for x. So we can divide by 15. Do this correctly, I think x is 6. Okay. Now what we want to do, like I said earlier, we want to check to see if our solutions are valid, right? So let's go ahead and just check to see if x equals 6. So what we get is -3 plus, and we get the square root of 15 times 6 plus 10 equals 7. So this is -3 plus the square root of, so 15 times 6 is going to be 90, plus 10 equals 7. So -3 plus the square root of 100 equals 7. -3 plus the square root of 100 is going to be 10. So -3 plus 10 is 7. And that checks to see that this solution is valid. Okay. All right. So I have one more example, and then that summarizes the video. Okay. So last example that I have looks something like this. Okay. So let's say I give you something like 4 times the square root of x plus 3 equals 8x. Okay, so what I see is, again, our goal is we want to isolate this radical somehow. So in order to isolate the radical, we need to get rid of the 4. So what we can do, in order to get rid of the 4, we can divide both sides by 4. Okay, if it helps, replace this with a variable. Replace this with like a y or something, or a z or something. So when you're trying to go ahead and like solve for x or something, basically what you want to do is to isolate that radical, you want to get rid of the 4. So what we can do is we can cancel. So this is square root of x plus 3 equals 8x divided by 4 is going to be 2x. Now what we have done is we have isolated the radical. So now that we have done so, we can now square both sides. Okay, now if we square both sides, square root cancel with the square, we get x plus 3 equals, and this is where I can see some of you also making a mistake. Some of you might just put 2x squared. Remember, this is 2x times 2x. So 2x times 2x in this case is going to be 4x squared. Okay, now what we want to do is we want to get all the terms on one side. So what I see is we can subtract x and subtract 3. As you can see, they're not going to line up. So we're going to subtract x and then subtract 3. So we're left with 0 equals 4x squared minus x minus 3. Okay, now a couple ways that we could do this. We could use quadratic formula. If some of you do not trust your factoring skills, you can use quadratic formula. A is 4, B is negative 1, C is negative 3. Or what you can do is you can use X method. So X method on this thing, let's see if we can do that. So we got 4 times negative 3. So that's going to be negative 12. We have a negative 1 here. So this is going to be negative 1. We need to find two numbers that multiply to negative 12 and add to negative 1. Yeah, multiply to negative 12, add to negative 1. That should be negative 4 and 3. Yeah. And then add. Yeah. And then what we want to do is we want to divide by our a term. So that's going to be 4. Okay. And now we reduce any fractions that we see. So negative 4 over 4 is negative 1 over 1. So this is 1x minus 1. So 1x minus 1. So in other words, that's x minus 1. And then what we have for this, right, this is going to be 4x. I'll help you guys out with the colors if you guys need help with that. This is 4x and then plus 3. Okay. Now, what we can do is we can go ahead and solve for x. So we have x minus 1 equals 0. Add 1 to both sides, and we get x equals 1. And then we have 4x plus 3 equals 0. So we can subtract 3 on both sides. So 4x equals negative 3. Divide by 4. And then we get x equals negative 3/4. Okay, so what we have here is these are two possible solutions that could come out of this. But it's also good to also check our work. We don't need this anymore. So we need to check our work with this. So let's just check. Let's try x equals 1. So if we try x equals 1, let's plug it back in. 4 times 1 plus 3 equals 8 times 1. So we get 4 times the square root of 4 equals 8, because 8 times 1 is 8. Square root of 4 is 2. 4 times 2 is 8. That works. So it looks like this one is a valid solution. Let's see if we try the other one. Let's try plug this back in. Okay, so we get 4 times the square root of negative 3 over 4 plus 3 equals 8 times negative 3/4. Okay, let's see. This is where the math gets kind of fun. So this is negative 3/4. Find a common denominator. That's going to be 12 over 4. 12 over 4 is 3. Let's see. 8 times negative 3 is negative 24. Negative 24 divided by 4 is negative 6. So we got to see if we get negative 6 somehow. Based off this, I don't think that's going to happen. This is 4 times the square root of. So we have common denominators here, so we can add the numerators. So we have 9 over 4, and this goes back to that algebra rule, right? So this is 4 times the square root of 9 divided by square root of 4. So this is 4 times 3 divided by 2. So in other words, what we have is, well, 4 times 3 is 12, 12 divided by 2 is 6. So when we bring this down here, this means that, well, 6 is not equal to negative 6. So I know that was a lot of work, but basically, as you can see here, this means this solution is not valid. And only x equals 1 is going to be the valid solution. So, yeah. All right, and that pretty much sums up the 5 problems that I wanted to go over. Okay, please let me know if you have any questions on anything. Okay, bye-bye.